over to you.
Thank you.
Miguel.
Thank you, Gustav. Thank you for being here. A warm welcome from my side. My name is Michael Hummer. I'm here on behalf of Fronius International, and I would like to give you an overview about Internet of Things, Industry 4.0, this buzzword, which is all about, and in the end, the impact on welding in the future. Very theoretically, but I have to say thank you to two of my colleagues. They were creating a white paper. I can show you later on. It's available online, which describes this matter even better. And Helmut Ensbrunner and Gerhard Posch. But it's only me, which is now between you and the light lunch. I hope it's a lot lunch, not light lunch, but we will see afterwards. So I will consider not to take too long. The outline of this presentation is following that I will have first of all a short theoretically thing about Kondratiev, Internet of Things. What is this all about? Then Industry 4.0 and my personal impression to it. And then furthermore, the implication on gas metal arc welding then. And what we do need in a welding power source to fulfill Industry 4.0 standard. In the end, I will go to also some welding challenges, which is virtual welding, metal additive manufacturing, which is also playing in this game, and then a final conclusion. But let's start with the Kondratiev cycles of technical innovations. This guy, he was monitoring the technical achievements in relation to economic development. And we do see the cycles, and we are right now in the 6th cycle or beginning of the 6th cycle of biotechnology, nanotechnology, renewable energies, smart grids, cloud computing, and Internet of Things. These cycles are always 40 to 60 years, and always with depression, rise, falling down, and so on. The Internet of Things, the digitalization and worldwide networking. The overall goal is to provide any information about things, about any kind of machine, to a huge digital community through Internet and make it available. The basis for Internet of Things is the digital transformation of every company. The consequence of it, to get big data. And furthermore, to get knowledge by systematic analyzing these big data which are available. The implication of it is we will have new possibilities in the future with new business models. And one thing for sure, software will play a very dominant role in all of the machines and all technical machines in the future. Industry 4.0. What is this buzzword? And here my personal impression to it, and of my colleagues as well. It's a very successful marketing term, especially in the German-speaking countries, where it's often used for the next degree of industrialization. But also, it's to gain attention from politics, governments, to get more fundings for companies, especially working in technology. It defines a certain kind of global product strategy, and this strategy should be implemented by many production equipment manufacturers to finally enable a smart production. Of course, Industry 4.0 awakened the market as well. Yeah? Every technical company producing technical equipments need to question itself, are we taking part of it? Yeah? Are we doing this sufficient or not? And what is Industry 4.0 all about? Yeah? Personal definition, Pedro, you said it, we need teamwork. Yeah? And Industry 4.0 is also teamwork. On a very basic level, said, what proved to be rights for humans and humans should be now introduced between machine to machine and machine to human. Production lines, they should consist of intelligent subcomponents. These subcomponents can network to each other, exchange data to each other. And of course, these all will lead into the goal and the target to get cheaper production, where we were able in the past to have a mass production to get the costs down. Now these companies will be able to produce low quantity products on a mass production costs. And the teamwork idea is not just the production itself, it will also include suppliers and customers to this team. Yeah, future smart factory. From conveyor belt driven manufacturing, we will have much more higher flexible, and there will be a master control unit, yeah, a so-called computer, yeah, and he will take decisions which manufacturing cell takes over if the other one is down, or vice versa. Yeah. The focus is to be very, very efficient in the data reporting, to provide the data to the total mastermind. Yeah, what constitutes teamwork? Yeah, the personal definition is at least we need to have a common language to all of the machines. Now we're coming to the critical points already. Yeah, every manufacturer of technical equipment in a production plant do have their own language. Yeah? So we need to have at least one common language in these machines. All team members know the common goals and pursue them. They estimate their own skills, and the workload will be balanced according to this. The team members help each other to solve the problems, especially when the goals which are set it up are in danger. And there exists a team leader who is in charge of inducing these properties to this team. And this is not a human anymore. Yeah, this is clear. Yeah, in Industry 4.0, all this teamwork behavior has to be transferred from machine to machine or human to machine, all in a collaboration. Very theoretically, yeah, but this is just the beginning, the start of what I mean then with the welding machines. What does it mean then? Because we are coming now to complex problems in the future. And how to solve complex problems? A welding machine will do different things in the future. Eh? Of course, it's not usable, yeah. But you should see there are many calculation and algorithms in the welding machine, which is needed for the future, which is needed for production. And I will come later to it, because here we are now going to the impact on welding, on gas metal arc welding especially. When we think about Industry 4.0, we need to think about following topics that play a mandatory role. Yeah? We need to digitalize the welding knowledge, which is now on every welder, on every welding responsible. We need to have a very fast microprocessor-based welding power source. We need to have a very, very fast data communication. We need to have welding parameter selection and the data storage in a welding machine. And of course, we need to save this data and provide a certain data chain. And furthermore, we need to know where the welding torch is positioned on materials. And we need to make sure that we have a good communication between human and welding machine. And of course, welding machine to any kind of machine. Digitalized welding knowledge. Yeah? The perfect seam, the perfect result of welding is a combination of perfect process, perfect filler material, perfect technology all about. Yeah? Much knowledge about welding is needed to define and to choose the best option. Yeah? When you think about yourself on welding, yeah, there are many ways to solve one topic. Yeah? But to define what is the fastest and the most efficient and safe way, this is always still welding responsible. Yeah? A man, yeah, or a woman, yeah? Human. Microprocessor-based welding power source. Yeah? These Industry 4.0 ready welding machines have following requirements. We need to have a self-detecting of installed components. So it doesn't matter which torch is connected, the machine need to recognize this. Yeah? A restriction of the welding power based on what is connected. So if this is 500 amperage power source and we do have connected 230 amps torch, the machine automatically gives you not more than 230 amps out. Just don't, that the torch will not be destroyed. This is all available. Of course, this must prove and provide all networking functions. Yeah? So this machine must be in a network with its own IP address. Yeah? Welding data measurement and storage. Yeah? We need to find real value welding data in front of the arc and measure them constantly and store them. And welding parameter control, there need to be a certain algorithm how fast a machine can then react on existing boundaries, on existing changes. Yeah? I will come to that within the next 2 slides. Of course, if you change synergic lines during welding, yeah, which is possible on even robotic and manual welding, you need to have a very fast change of the synergic line. And such systems must be really within electromagnetic compatible. Data communication. Yeah? Mandatory for these welding machines is a real-time communication. Real-time means the communication time between the arc or what is happening on the arc and the processor and change of a welding is within or smaller than 30 microseconds. Yeah? Including measuring of the data in front of the arc and digitalize them in the welding machine and then change this data in front of the arc again. Yeah? So when we think about CMT welding, yeah? CMT welding, the wire is moving constantly forward with 150 Hertz forward-backward movement. And every single time, the welding machine is calculating amperage, voltage, wire feeding speed, and all parameters in the back. And to react on it, you just have time of 7 milliseconds to react on a droplet detachment, which is done already. Yeah, and of course you need to make sure that these functions are also working under harsh industrial conditions. One example for this is here. You know, when you're welding and your stick out will change, yeah? You will have more stick out, the voltage is rising, amperage is falling, you will lose some penetration. But we don't want to lose penetration, especially on robotic welding in automotive industry, for example. You don't want to lose any penetration. So first I will show you now a video where you see where the torch is moving constantly more far away from the workpiece, and you see on below the penetration. Stick out is getting higher, and you lose penetration from 4.2 to 3.4 millimeter. And the next thing is where we are activating the welding machine to react on these changing conditions, and you will see that these changing conditions, the machine is recognizing because of measuring of the welding parameters and reacting on it with additional wire feeding speed, for example, to get the same penetration level as it should be. Constantly wire feeding is increased. So there must be intelligent stabilizing functions in a welding machine who can create, still on changing conditions, a good impact on the welding result. Welding parameter selection and data storage. Yeah? A powerful and fast data management is really mandatory, yeah? To digitalize, monitor, record, and control the welding parameters. Of course, these data storage things has to be very fast and reliable. Yeah? Also, you need to have in the back algorithm functions who can react on changing conditions or on imperfect welding conditions, as well as when the machine must recognize in the future when you need to change spare parts, yeah? Contact tip, inner liner. The autonomous parameter selection is still limited by the digital accessible knowledge right now. Big thing is on Industry 4.0, the data security. Yeah? As you provide, and we share this big data via the network through maybe a cloud or server-based activity, we need to enable a more efficient data analysis, yeah, to get more solutions than for customers in the future. We need to have common data standards, yeah, and interfaces in between these machines that they can communicate to each other. Yeah? But we need to make sure that all these machines are really safe against cyber crime. Yeah? And this is, from our side, it's not just software, but it also has to be really safe against hardware issues. When someone is just plugging in via Ethernet on the machine direct. Yeah? So you really need to make sure that the welding machine or other machines are able to be really safe. Yeah? Our R&D guys call this Pentagon standard in our systems. Yeah? And the data chain with it. Yeah? When we start to collect digital data, also from customers, yeah, from our own systems, then we need to generate this data, engineer it, make some analytics. Yeah? Out of this we get some knowledge, what we can use for the future. Yeah? What can be good for customers, but also interesting for us. But one thing for data all about is they have to be correct, completed, and structured. Otherwise, they are worthless. And here is a big thing. What kind of data we want to have and with which data we want to work in the future. Welding torch position. The knowledge that we know where the welding torch is positioned at every single moment is really essential for autonomous welding cell, yeah, of course, but to describe the influence of the base material, to have the influence on heat input in the material, then to select the proper welding processes and the parameters in the back, and we can do the optimization of torch before and after welding. Yeah? And also we need to know the torch position exactly for the weld documentation afterwards, what we can handle to the end customers. But this all is possible already with robotic welding, because on robotic we know usually where the torch position is exactly and how fast we are welding for the heat input. There are laser camera systems where we always know what kind of geometry we have and how fast the welding must be. But absolutely challenging for the future, and this is not applied yet, is to have so close sensors on the manual welding torch near the arc because of heat and radiation. So this is some topic still for the future. Communication, very, very important thing. Humans will stay the responsible operator of a welding machine within the next decades. This is essential. But to make it much more easy for an operator to handle it, we need to have multi-language operation, and we need to have like mobile phone structured, easy, haptic operation. What you have with a touch display, with all different functions, what you see, like a child can learn it. And essentially is that, for example, Iceland, that you have Icelandic language in the front panel. And for what is coming right now is the integration of the welding helmet to the welding system. That we have, for example, communication possible between the welder with the helmet to the welding machine. And according to the amperage size, what we are welding, the shade level of the helmet is automatically adapted. If you have more amperage, the shade level will be darker for the welder. Let's coming to some welding challenges. Virtual welding. it's coming more and more, and this is really something where we could do some presetting in the future for companies, yeah, where we see before going into autonomous welding, we can virtually map all the welding procedures on a workpiece. Yeah? And there we can check the correctness of the robot offline programming. Then we can do, during this test procedure in virtual welding, we can optimize the parameters, or we can adjust the welding speed, torch positions, and the movement. Yeah? And another thing what is also in Industry 4.0, and a colleague will come later to it with additive manufacturing, is this wire arc additive manufacturing is a very hot topic. Yeah? This is it's all about now. The radar high deposition rate of arc welding systems with very less spatters and a perfect arc control gives you a lot of possibilities nowadays. But we also need to rethink what it is. It's not joining anymore, it's building up a structure. And this is just one example what can be done. Yeah? This is a simple geometry, more or less. Yeah? But I have here also a video for this where you see the build-up of such a structure. And it's not the build-up. What makes me amazing here, it's the camera is synchronized with the welding machine. So this is already Industry 4.0 solution. The camera system is linked with the welding machine because you see no arc here. So the camera detects exactly with the welding machine where the arc or the short circuits happened. So when you have real deep welding challenges, Fronius may help you. So, coming to the end, more or less. Yeah, I know this is sometimes for me, even for me, hard to understand Industry 4.0. What is coming up? It's one of the most used technical terms. Yeah, the vision is to digitalize and provide valuable data for a huge community, to a larger community. And then doesn't matter if it's for a welding machine manufacturer or for a manufacturer who is using welding machines, it must have the big goal to have more economic solutions. The overall goal is to be autonomous in working in these factories, yeah, based on the digital information, the big data you are getting, what you get from the cloud. And the impact on welding is more or less the digitalization of welding knowledge and the welding data. This is a requirement to get. Yeah? And then the welding machines, they really get more computerized, much more modern, with very fast microprocessors who can react on changing conditions all the time. It must be network controllable, and there will be a lot of software play really a mandatory role. The high-speed data is needed, and a very intelligent human-to-machine communication is necessary. Good. In the end, I have one more video where Industry 4.0 interaction human to welding machine is shown. thank you very much for your attention. And if you have questions, just start.
Thank you. Georg og klart. Og ef það eru spurningar, gjörðu svo vel. Sjáum við þarna hvernig
Lunchtime is coming. Yeah.
við munum á eftir tala til dæmis staðla sem koma að þessum material addi hjá norsku kannski hvernig þessi tækni að verða leyfð inn í þessu skipaiðnaði og þetta náttúrulega eins og við vitum lítil flytting eða material addi efni sem framtíðin. Svo ef ekki spurningar þá þökkum við fyrir. Maturinn kemur rétt tónleiti, svolítið að það tími kannski fyrir súrefni og að tegja úr sér og svo þurfum við hérna að fá nokkur matvættir.
I just have one more thing about this thematic Industry 4.0. There is a blog for blog.perfectwelding from Fronius, and there is this white paper. Yeah? This white paper is really made for Industry 4.0 and welding technology. Here you can download this white paper in English, yeah? where you see really the influence on welding for Industry 4.0. Yeah? This is just a short overview from my side. If you want to have deeper information, there is this white paper available. Thank you so far.
Thank you,